So the goal of this question is to express everything as a single logarithm. So currently I have log 5 base 5 of 10 plus 3 log base 5 of 6. I want to go ahead and pull that exponent up. Log 5 of 10 plus 3 log base 5 of 6. I'm going to pull this exponent of 3 up. And I'm going to write that as log 5 base 5 of 10 plus log base 5 of 6 to the third power, which is what? Which is 216, I believe. So we have log 5 of 10 log base 5 of 216. Now, the sum of the logs is the log of the product, so this would be log base 5 of 10 times 216. So we'd write this as a single logarithm as log base 5 of 2,160. The next example I have is 2/3 ln 27 minus 4 ln 3. And again, our goal is going to be to write this as a single logarithm. Is there a way for me to rewrite this so this becomes a single logarithm? So again, we're going to pull these exponents up. So that'll be the 2/3 is going to become 27 to the 2/3, and the 4 is going to become 3 to the 4th. So rewriting this as natural log 27 to the 2/3 minus natural log 3 to the 4th power. Now, what is 27 to the 2/3 power? Well, if you're not sure, we certainly can do it here. 27 to the 2/3 power, just watch your order of operations, is 9. Now, how do we get that? Let me just show you off to the side here. 27 to the 2/3 is 27 to the 1/3 squared, which is the cube root of 27 squared, which is 3 squared, which is 9. So I get ln 9 minus ln 3 to the 4th. 3 times 3 is 9, times 3 is 27, times 3 is 81. And the difference of the logs is the log of the quotient. So this in turn equals log of 9 over 81, which reduces to natural log of 1 over 9, which again, I can still work on a little bit, right? I can still work on this because this is natural log 1 minus natural log 9. Natural log 1 is 0, right? E to the 0 equals 1. 0 minus natural log 9, and the result I get is minus the natural log of 9. Now let's check that on the graphing calculator. So we had 2/3 natural log 27 minus 4 natural log 3. Let's see if that really is the same as minus the natural log of 9. So again, here we go, 2/3 times the natural log of 27 minus 4 times the natural log of 3. And we get this answer. Is that the same as minus natural log 9? Minus is here, remember. Natural log 9 gives me the same thing. So indeed, we feel good about that. That one is correct. And I have one more of these, a couple more of these I want to do. Next up, we have log base a of x log base a of x plus log base a of 7 minus log base a of x squared plus 5. So we'll start with the first pieces. The sum of the logs is the log of the product. So log A of x plus log A of 7 would be log A of x times 7. Log base A of x times 7 minus log base A of x squared plus 5. X times 7 seems a little strange, so let's rewrite that as log base A of 7x minus log base A of x squared plus 5. Now what? Now the difference of the logs is the log of the quotient. So we'll rewrite this then as log base A of 7x over x squared plus 5. That's how we can get this as a single logarithm equivalent to what that original statement was. And we have another problem to do. Let's quickly look at that one, which is 2 log x. If I don't write anything, it's log base 10. 2 log x minus 3 log y minus 5 log z. The goal is to write this as a single logarithm. Well, let's pull all of the exponents up. So just copying it to emphasize that fact, 2 log x minus 3 log y minus 5 log z. Let's pull all the exponents up. The 2 comes up. 3 comes up. The 5 comes up. So I get log x squared minus log y cubed minus log z to the 5th. So I have the difference of these 2 logs, difference of the logs. Difference of the logs is the log of the quotient. So rewriting that, that will be log x squared over y cubed. Then we're going to subtract minus log z to the 5th. So the difference of the logs is the log of the quotient. Log of the quotient, log of the first guy divided by the second guy. Log of the first guy, x squared over y cubed divided by the second guy, divided by z to the 5th. So just keeping in mind our rules from arithmetic, we get log x squared over y cubed times 1 over z to the 5th, and this finishes up as log x squared over y cubed times z to the 5th.